All right, when we solve quadratics by graphing, what do you look for? X-intercepts, good. When do you use the method of using square roots? If bx is missing, good. And when I mention bx, I'm referring to standard form, right? ax squared plus bx plus c, when that piece is missing. And then when we are solving by factoring, we need to make sure what? That we are equal to 0, okay? That was also pretty important when we were graphing yesterday, because you need everything on the same side before you can like type in your calculator, okay? Today, the whole thing needs to be equal to 0 before we start to factor. There's two main ways to factor: when your a is a 1 and when your a is not a 1. Okay, so we're going to go through both of those today together. First, there are some word problems on the back that I would like to do to kind of put it all together. But we'll see how far we get, okay? They're not necessary, but they're nice to do. So let's do basic factoring first. So basic factoring is when your a value is 1. So your equation starts off with just x squared and then something, something, something. Okay, that is basic factoring. So when we did basic factoring, again, make sure it's equal to 0 first. So what do we have to do for our first problem? We have the minus 45 over. Is that my A, B, or C value? It'll be my C value. So we actually are going to factor x squared minus 4x and then minus 45, like that. From here, so to factor something means we are essentially dividing. It's the opposite of FOILing. It's the opposite of distribution. Okay, we're working backwards. We're taking it apart. So I want two factors of x plus and minus something, x plus and minus something. Okay, so to figure that out, two numbers have to multiply to give me negative 45, and the same numbers are going to add together to give me negative 4. Remember doing that little puzzle? Okay, what you think?
9, negative 5.
Some kind of a 9, some kind of a 5? Do we agree? Yes? So one of them has to be negative because we have negative 45. So something has to be negative. So we know it's 9 and 5. So think, is it 9 minus 5 to get negative 4? Or is it 5 minus 9 to get negative 4? 9, oh, I lied. 5 minus 9. Okay. Every teacher has their own way of going about these things. This is how I go about it. Okay. There's lots of little tricks and shortcuts. I'm not a big fan of shortcuts because I want you to understand like why we're doing things. Okay. Were you going to say something about the signs?
Yeah.
Like since 4 is negative, then your bigger number is negative? Okay. Okay, that's another trick also. The sign with the middle number is the sign of the bigger number. Like 9 and 5, 9 was bigger, 9 was negative. That's another little trick. But again, I don't like memorizing. I like understanding what we're doing. So that's how I go about things. I'm not done though. I have factored the problem. It has been factored, but I have not solved the problem. So what does x equal? Okay, so up here it says using the zero product property. That just means we take each parenthesis and make it equal to 0. Okay? Makes sense, right? They're called zeros. Yeah. So we're going to get x equals negative 5. And over here, x equals positive 9. Okay? That step right here, come on. Thank you. Right here is a step that some people skip when you get really fluent with it, and that's okay. Because remember, inside opposite. So x plus 5 gives me x equals negative 5. So that's fine. Pull it out, change the sign. All right, what is my issue with the next example? It's equal to f of x. Well, I don't want it to be equal to f of x. That's function notation. That's nice. But I want it equal to what? 0. So x squared plus 12x plus 35 5 equals 0. There we go. All right. Here we go. Two numbers to multiply to give me positive 35. So guess what? They're both going to be the same sign, right? They have to both be positive or both be negative. And they have to add to give me positive 12. Positive 7, positive 5. Because 12 was positive, that told me they were both going to be the positive sign. All right, so what are my solutions? There you go. X equals negative 7 and x equals negative 5. Again, what part of the graph are we finding? X-intercepts. What's up?
So, like, for writing it out, like the answer, do we have to write it out like that, or can we just write x equals negative 7, comma, negative 5?
That's fine. Yeah, that's fine. Like this?
Yeah.
Oh, negative. Yep, that's fine. And then you can even do it like this also to show like the squiggles show a solution set. So that's still the same thing also.
Is that
Usually, yes. All right, think you can do some? Yeah? You try. Let's see. Let's see if you can do a couple. All right, check your work with mine. So the first one, there was a couple of ways to go about it, okay? The blue shows you that I factored out a GCF, a greatest common factor, okay? They both shared an X, so I divided X out front. Again, it's opposite of distribution. So I brought it out front and then made each piece equal to 0. So I get X equals 0, X minus 8 equals 0. So X equals 0 and X equals positive 8, okay? The gray shows you that you could do it the way we were just doing it before and you wouldn't be wrong. The C value is technically 0. It's not there, right? So if you wanted to make it x squared minus 8x plus 0 equals 0, perfectly fine. What multiplies to give you 0 and adds to give you negative 8? That would be 0 and negative 8. So you have x plus 0 in the factor, x minus 8 in the factor, solve, we get 0 and negative 8 again. Okay? So two different ways you could have gone about that first problem. And then our second one, you had to subtract 8 first. And we get our solutions of 2 and negative 4. How are we feeling?
no,
Great.
So this is a review, right? This isn't new stuff. So if we are lost on this, make sure I'm seeing y'all at lunch or at tutoring. Because this is a reminder because we're building on this very fast. So if you are struggling, I need to see your face in my room. Not today lunch though. I have a meeting. Any other lunch? Yes. Except Monday. Lunch tutor. All right, are we ready for slip and slide? So what you just did covers the front of your homework worksheet that you picked up. The front is all A equals 1. All right, the back is when A is not going to be 1. So this is a method that Miss Douglas calls slip and slide. Okay, some teachers call it the cloud method. Some teachers teach guess and check, not my favorite. But some people just work that way. I don't. Okay. Okay. So with slip and slide, y'all listen. So slip and slide uses basic factoring. So what we just did. So if you're still kind of stuck on basic factoring, you're about to get more practice. Okay. With slip and slide, you have to slip your A value to the end of the equation by multiplying. I'm going to show it to you. Then basic factor, and then slide, which rhymes with divide, that A value back out. Okay? So that's why it's called slip and then slide. So let me show you what all that means. So 2x squared minus 11x plus 12 equals 0. Okay? My A value is a 2. I can't divide 2 out. That would have been nice, right? If that 11 was a 10. Because then you could just divide by 2 and then do what we just did. But we can't do that. Okay? So I'm going to slip my 2 to the end of my equation by multiplying. So now I have x squared minus 11x plus 24. Okay. Just the 2. Yep, you're slipping it to the end. This is the slip part. Okay, slip your 2 to the end. So you're multiplying it with your c value. Right? So this is a times c. Now we're going to basic factor like we just did above. So what multiplies to give us 24 but adds to give us negative 11? It has to multiply, though, to give me 24. Some kind of an 8, some kind of a 3. Are they both going to be positive or both be negative? They're both going to be negative. Okay. So we've done the slip. We've done our basic factoring. And now we're going to slide or divide the a back out. So we're going to slide 2 out of each of these. Because we kind of manipulated the problem to make it easier, but we have to undo what we did to make sure it's in the right format. Okay? Because if I were to actually FOIL those 2 back together, I'm not going to get 2x squared minus 11x plus 12, right? I'm not going to get what I started off with. So to slide the 2 back out is to divide. So what is negative 8 divided by 2? Negative 4. So this is x minus 4. And yeah, this one can't simplify, so we're going to leave it just like this. So now, what are my 2 solutions? 4 and 3 halves. X equals 4 and x equals 3 over 2. What's up?
My teacher showed it was instead of making it 3 halves, since it can simplify.
Yes, so factored form, if you wanted factor, you mean this? Oh, that's not 3. That's a 2. Yes, that is the same thing. And then when you solve for x, you add 3, divide by 2, you still get 3 halves. So yeah, that's technically the same thing. You're just giving yourself more work. Is what it is. But this is the complete factored form. But when it comes to solving, we're allowed to solve at this step. Yes?
Are you ever going to ask for that start step?
Later, when it says factor, if you're not solving, if we're factoring completely, then that's when this happens. But today, we are solving. So today, we don't have to do that. All right, my next one, 2x squared minus 8x plus 6. I could just get rid of the 2. But before any of that, I have to do what first? You have to make it equal to 0 first. Okay, so if you do recognize a GCF, use it, okay? You can factor out the 2. And then we have x squared minus 4x plus 3. This isn't a slip and slide anymore, is it? I can just basic factor and call it a day. What multiplies to give you 3, but adds to give you negative 4? All right. So that's something we got to be careful with. When I solve this, what are my x values? 3 and 1. Is that 2 a solution? Say no. No, it's not with an x, right? Solutions are the x values. 2 is just a vertical stretch, right? It stretched it. It has nothing to do with your x-intercepts. So from here, I can say x equals 3 and 1, okay? Now, what if you didn't recognize there was a GCF and you went to go slip and slide? Would you get the same thing? I hope so. Let's see, yeah. So if you did not recognize GCF and you went into slip and slide, I want to show you that. Okay, so up here, we recognize GCF. Okay, here, we're going to do slip and slide. So if I slip my 2 to the end, we get x squared minus 8x plus 12 equals 0. All right, what multiplies to give us 12 but adds to give us negative 8? negative 6, negative 2. Then we're going to slide the 2 back out. What is 6 divided by 2? And then we get x equals 3 and 1. Okay, so when it comes to solving, you're good either way. To go back to the complete factored form, because these both simplified, I would have to remember to put the 2 out front because they both were able to be divisible by 2, technically. But again, that's something we're going to do later. That's not something you have to worry about right now. There isn't one. Nope. All right, you ready to try? Let's see if you can try slip and slide. We have 3x squared minus 5x equals 2. And we have 4x squared plus 28x plus 49. So try it with those two. All right, check with me. So the first one, you did have to subtract 2 first before you did your slip and slide. So subtract that across the equal sign. Then slip your 3, factor, slide your 3. We end up with x equals positive 2 and x equals negative 1/3. Yes? Thumbs up? We're good with that one? Okay. The next one was only a doozy because it was a big number and you got scared. Okay. So when you slide your 4 across, because there is no GCF, you cannot divide the whole thing by 4 or 2. It's not going to happen. Okay. Slide your 4 to the end and you do get 196. So then you have to figure out what multiplies to give me 196 and what adds to give me 28. If you know your perfect squares, hopefully a bell rung, because 196 is 14 squared. And 14 and 14 is 28. But if that bell didn't ring, that's okay. Maybe the bell ringer's on a break. Okay? You can get a list of factors in your calculator. Okay? If you go to y equals and type in 196 divide by x, any number divided by x, and then go to your table, all of your whole number pairings are your factors. So it'll show you 1 and 196. It'll show you 2 and whatever that is. Yes, I did. Okay, so there is a way to get your list of factors. So like if you go to y equals and you do 196 divide by x like that, and then you go to your table, so second graph, wherever there's 2 whole number pairings, those are factors. So negative 4 and 49. Well, that can't give me 28, right? Negative 2 and 98 can't give me 28. Negative 1, negative 196 can't give me 28. See how we're using the table? Okay. So all we care about is our whole number pairings. 4 and 49. 7 and 28. That's not going to give me 28. Oh, look at that. 14, 14. So I know they multiply to give me 196. They also add to give me 28. So that's a way to get a list of factors, okay? But I was hoping you recognize the perfect square. But if you didn't, that's okay. It's Friday. Lots of ways to do these problems. So then you had to slip the 4 back out of them. So they both become x plus 7 over 2 is how that simplifies. So you only have one solution at negative 7 halves. So this is a special parabola, right? That's also the what? After the V. It's also the vertex. Okay, so this one is sitting on the x-axis. Oh yeah, don't forget. If you slip, you gotta slide. Don't forget to slide. Hold on. It's the same thing as x's. It's just a different variable. That's a 1 in the middle. Yeah. Hold on. Hold on. All right, kids. Does anyone still need this before I scroll away? What's that? Yes. quadratic formula will solve any quadratic equation. Yep. That would do it every time. As long as it's x squared, the quadratic formula will solve it. These are just shorter ways to get things done. Quad formula takes a while. And there's lots of chances to make mistakes in the quadratic formula. So we try to avoid it, but sometimes you got to use it. And we will use it. It'll happen. All right, lovelies. I actually want to go down to this problem first. I want to go down to this one. So when an object is dropped, okay, its height in feet above the ground after t seconds can be modeled by the function h of t equals negative 16 t squared plus s sub 0, okay, where s sub 0 is the initial height in feet of the object. The graph of h of t equals negative 16 t squared plus 200, that would represent the height of an object that's being dropped from 200 feet up in the air, okay? And that's what's being shown to you on the left. This assumes that the force of air resistance on the object is negligible, okay? This model also only applies to objects dropped on Earth because different planets have different gravitational pulls. This equation only works if the object is on Earth. Okay. So, let's work with this. For a science competition, students must design a container that prevents an egg from breaking when dropped from a height of 50 feet. Okay. So let's write a function that gives the height in feet of the container after t seconds. So let's just write a general function. So we're going to say h of t, so the height after time, equals what? Negative 16 t squared, and then what's our initial height? That positive 50 feet. So now we're going to use this to answer our next question. How long does it take the container to hit the ground? So that's my height, right? The whole thing equals what? Let me make the whole thing equal to 0. Okay. We've done a couple of methods yesterday and today. Which one are we going to use to solve this particular problem? The square root thing. Isn't my bx missing? Yes? So this is going to be the method we used yesterday. So the first thing you're going to do is subtract 50. Then we're going to divide by negative 16. This is real world, so we will use decimals. That's one nice thing about real world stuff, right?
Sure.
Usually you don't have to simplify radicals. All right, so that gives me, what, 3.125? And now what do we do? Square root both sides.
What do you want to approximate?
Let's just do a tenth.
Okay, so 1.8.
About 1.8? Okay. So technically, t equals positive and negative 1.8, right? Can I have two answers, though, to this question? No, which one of those does not make sense? The negative. Again, real world situations here. We can't go back in time. Not yet. Not yet. So we can't say it takes negative 1.8 seconds for it to hit the ground. So we're going to say it takes 1.8 seconds to hit the ground. So that kind of ties in yesterday and today. I want to give you time to work on your assignment, so I'm just going to stop right here. Is that okay? So I'm going to stop. That was just like a little tie-in for our 2 days. Your homework, though, is just factoring with A1 and A not 1. So use the rest of class today to work on your assignment. right?
Higher